The question is explain op-amp summing amplifier, okay? And that too it is inverting. So what is meant by summing amplifier? You know that summing amplifier is a circuit in which it sums more than one inputs, right? So I can define that the summing amplifier is a type of operational amplifier circuit configuration that is used to combine the voltages present on one or more inputs into a single output voltage. Okay, so if we can draw the circuit diagram, so what will be your circuit diagram of your op-amp summing amplifier? The question asked is inverting, right? So inverting, we have to draw the inverting op-amp. So minus plus inverting terminal, non-inverting terminal, output V out. Okay. So inverting summing amplifier means the inputs will be applied across the inverting terminal and the non-inverting terminal will be grounded. Okay. So let us consider that we are taking V1, V2 and V3 are the three inputs applied. Okay. So what will be your output? Output should be the sum of three inputs. Okay. So let us take this as resistor R1, R2, R3. So let us assume that the current flowing through R1 is I1, current flowing through R2 is I2 and current flowing through R3 is I3. Okay. So here it is an amplifier which you will be having inverting amplifier. So you will be having a feedback resistor. Let us take it as RF. So if I take this as node A, since the non-inverting terminal is grounded and due to negative feedback here also it will be in virtual ground, right? So the value at node A will also be equal to 0. Okay. So let us take or assume the current flowing across your feedback resistor is equal to IF, and we are assuming that it is an ideal op-amp, so no current flows inside the op-amp. Okay. So these are the assumptions. Now if we go for your analysis, so what will be your analysis? I can take the Kirchhoff current law at the node A, right? So at node A, taking KCL, what you will be getting, the current flowing towards the node is equal to current flowing away from the node. Here the current I1, I2, I3 is flowing towards the node, right? And the current IF is flowing away from the node. So what will be your value? I1 plus I2 plus I3, which is equal to IF, right? Now, so can you substitute the value for I1, I2, I3 and IF now? What is your I1? I1 is the current flowing through your resistor R1. So what is V by R, right? If we apply V by R, V1 minus 0 divided by R1. So I can write it as V1 divided by R1. Similarly, what will be your I2? V2 minus 0 divided by R2. So it will be equal to V2 divided by R2. Similarly, V3 minus 0 divided by R2. So V3 divided by R3, which is equal to what is your IF? The current flowing across your resistor RF, right? So 0 minus V out divided by RF. So you will be getting 0 minus V out. So you can write it as minus V out divided by RF. Okay. So what is our aim? You have to find out what is your output voltage. So V out will be equal to RF into V1 by R1 plus, so it will be minus, right? Minus V2 divided by R2 plus V3 divided by R3. Okay. So if I can rewrite it as minus RF by R1 into V1 plus RF by R2 into V2 plus RF by R3 into V3. Okay. So this will be your V out. So if I assume that R1 is equal to R2 is equal to R3 is equal to RF is equal to R. So if I take the assumption that R1 is equal to R3 is equal to RF is equal to R, then R will get cancelled, right? So what you will be getting, V out will be equal to minus of V1 plus V2 plus V3. Output is the sum of all the inputs. But why did you get this minus? Because you can see that the inputs are applied across the inverting terminal. So what will be your output? So the output will be inverted of that of your input. So I can write that V out is equal to minus of sum of the input voltages. So since you have it as your inverting summing amplifier, you got a minus.